Hi guys, so this is for if you missed the Google Meet this morning or you just want a refresher while you're taking your puzzle pieces. This is about transformations. So I'm just going to hit join. All right, so it says translate figure KLM 8 units to the right and 4 down. Count each point separately to make K prime, L prime, M prime. So we did this a few weeks ago. Let me clear that dot off the thing. All right, so how I would have done this when we first talked about translations is I would have counted 1, 2, 3, 4, 5, 6, 7, 8. And then I would have gone down 4. 1, 2, 3, 4. So the other way that I could say this is because I'm moving to the right, just like on a number line, I'm adding 8. And going down is like subtracting 4. And what I mean by that is I can take this point, well, K is at -4, +8. Well, -4 is my X, and that's the thing that I'm going side to side with. So it's going to be X plus 8 and Y minus 4 for each of these points. So that would have been K. M, I could have done 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2, 3, 4. L, same thing, 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2, 3, 4. And I would have had my new, not quite, triangle. Okay? So there's my new triangle. It's been shifted down and to the right. If I didn't have this in front of me and I only had these rules, if I only had these rules and a point, say with, let's use point M. M is at -2, 1. So -2 is my X. So I could say, well, -2 plus 8. Well, I know -2 plus 8 is 6. Well, if I look over, I move point M to right above the 6. M is at 1 for the Y minus 4. Well, 1 minus 4 is -3. Well, look at that. I am at -3. So my new point for M was 6, -3. And I used math to do it instead of just moving it over. So that's what we're going to look at today. All right, so translation rules. Remember, X means right to left, and Y is up and down. Okay, X-axis is right to left, Y-axis is up and down, same thing. So when I am adding something, it either means I'm moving to the right or I'm moving up. If I'm subtracting something, I'm moving to the left and moving down. So X minus 3 is like going down the number line, so I'm moving to the left. And Y plus 2 means I'm going up 2. So for this one, I'm going to click that it means left 2, left 3, up 2. All right, so this next one says I have a point and I have X plus 5, Y minus 6. Well, X plus 5, I'm increasing, so I'm moving to the right. So I'm moving right 5. So I either have right 5 up 6 or right 5 down 6. Well, I'm going to look at Y minus 6. Minus 6 means I'm decreasing, so I'm going down. All right, one more translation. I have X minus 1 and Y minus 3. So X, remember, means left to right. Minus means I'm going to the left. So I'm going to go left 1. Well, I have this one, it means left 1. Sorry, this is left 1. Or this is left 1. So I'm either up or down 3. We need to make that determination by looking at Y minus 3. So Y minus 3, I'm getting smaller, I'm decreasing, so I'm going down. So I'm going to go left 1, down 3. Next one. All right, this is a reflection, which a few weeks ago we learned about, where however many spaces I am away from the yellow line, in this case it's the y-axis, that's how many spaces I go in the opposite direction. So if I had M, I would have counted 1, 2. I'm 2 away from the yellow line, so I would have gone 1, 2 away this way from the yellow line. If I had K, I'm 1, 2, 3, 4 away, so I'm 1, 2, 3, 4 away this way. L was 1, 2, 3, 4, 5, 6, 7 away, so I'm going to go 1, 2, 3, 4, 5, 6, 7. So my new triangle looks something like this. Okay? I'm going to erase this in the middle so you see the triangle nice and clearly. Okay, so there's my new triangle. Now, if we look at, I'm going to use M as my example. M right now is at -2, 1. Well, I reflected it over, and this is M prime. M prime is at 2, 1. So if I look, this is M prime, and if I look, well, they're the same numbers, but if you look at this, they became the opposite. So -2 became +2. 1 didn't do anything with it. So when I'm flipping over or reflecting over the y-axis, okay, the x's change. So before we move on, I'm going to, if I'm reflecting over the x-axis, I want you to think, what will happen if I reflect this over here? Earlier we had the y-axis, so the x values changed signs. If I am flipping over the x-axis, what do you think will change signs? The x or the y? We're going to take a look at that here in just a second. So if the y is changing, I'm going to look down here. It says means flips over y and x changes. Well, x didn't change. X stayed the same. Means flips over the x and y changed signs. Y and -y. Well, I would say that y definitely changed signs because one was positive, one became negative. So that means that it reflected over the x-axis. So let's look at this one. I have xy to -xy. So did x or y change? Well, x changed signs, so that means it reflected over the y-axis. All right, we're going to look at rotations now. This is where it gets a little trickier. So rotation of 90 is 1 turn, rotation of 80 is 2 turns, rotation of 270 is 3 turns. Over here are the rotation rules. Okay, so if I have a point, let's say on 1, 2. Oops. And I'm going to make another point on 2, oh no, on 3, 2. So let's just make a line right there. So what happens if I look at 90 degrees? We're just going to focus on clockwise right now. If I look at 90 degrees clockwise, that means I'm going this, ooh, that's still a line. That means I'm going this way around my grid, okay? So it's saying that y and x are flipping spots. So this original point we said was 1, 2. So now my new point is going to be 2, 1. But we know if I'm rotating 90 degrees, I'm going to be in this quadrant right here. So 2 and 1 is going to be right here where it's going to be now 2, -1. So if I looked here, I flip-flopped. It was 1, 2. Now it's 2, 1. And the back number became negative because this was 2, -1. This point was 3, 2. It's a terrible 3. Sorry, guys. So I flip-flop it. So now it's 2, 3, 2, 3, 1, 2, 3. So now it's here because that back number has to become negative. So 2, -3. So here is my, I'm going to change the color so you can see it. Here is the new line. It's a little crooked. And I can keep going. So if I had 1, 2, and I'm going to now rotate it 180, I know that it's going to be over here. Oops, I keep forgetting to turn it onto line. I know that it's going to be over here. So 1, 2, I look over at my 180. Everything just changes sign. So positive 1, positive 2 is going to become negative 1, negative 2. So this is negative 1, negative 2. 3, 2 will just become negative 3, negative 2. So I count over negative 3, 1, 2, 3, down 2, 1, 2. I don't know why it keeps popping that up. So negative 3, negative 2. And here would have been the next line. Okay? Then the last one, if I do 270 clockwise, that means I'm flipping X and Y. So I had 1, 2. Well, now it's 2, 1. And now that first number is going to be negative. So 2, 1 is right here. Ooh, let me change colors. Let's do orange. 2, 1 is right here. So now it's negative 2, 1. And 3, 2 would be 2, 3, except now it's negative. So 2, 3, here we are. So this would be negative 2, 3. Okay, so the other thing that you can see is if I had rotated everything in this direction, oops, I'm off the grid. Okay, the black is called counterclockwise. So if you look at the chart, counterclockwise for 270 is the same as clockwise 90. Because if I started here, if I went 90 degrees clockwise, I landed here. 270 counterclockwise, 1, 2, 3. I would have landed in the same quadrant. So they are the same. So you just have to make sure you're paying attention to which way you are going. I know that's a lot of information, but we're going to practice. All right, so 90 degrees clockwise. We're going to switch the ordered pairs. So that's the first thing we're going to take care of. So we know U is 1, 2, 3, 1, 2, 3, 4, 5. So 3, 5. We know L is at 1, 2, 3, 1. X hasn't moved left or right at all. So X is going to stay at 0, and it's going to go 1, 2, 3, 4, 5. So these are my ordered pairs. Now I have left off the negatives for right now, just so that you can see what happens with the numbers. When I switch to 90 degrees, what that means is I'm going, and also it's 90 degrees clockwise, I'm going over into this quadrant. Everything over here is going to be positive, so I don't need to worry about flipping all those negatives around. All I need to worry about is switching the X and Y. So U prime is going to be 5, 3. So I'm going to go over 5, 1, 2, 3, 4, 5, up 3, 1, 2, 3. Here is U prime. L was 3, 1. L prime is going to be 1, 3. So I'm going to go over 1, up 3, 1, 2, 3, put a point. X prime was 0, 5. It's now going to be 5, 0. So I'm going to go over 5, 1, 2, 3, 4, 5, and not up at all. So I can connect here. Oh, that's not quite straight, but, and there is my new triangle. Now, I left off the negatives because I knew that in this quadrant, everything had to be positive. So all I needed to worry about was flipping these numbers from x and y to yx. So let's take a look at that on this next one. All right, so I'm going to pick a point. We started with A, B, C, D, E. We're now looking at A prime, B prime, C prime, D prime, E prime. Yes, I know it's annoying to say all the primes, but you got to. So let's look at C. So C was at, we're going to count over 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 and up 2. So 9, 2 is where C is right now. We're going to look at C prime. So let's look at C prime. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, negative 9, 2, negative 2. So C was 9, 2. C prime is negative 9, negative 2. So my order stayed the same. So X and Y did not switch places, but they did both become negative. So I went 180 degrees because I rotated not once, but twice to get over here. So that is when X and Y stay the same, they just become negative. Let's look at this one where I have triangle FGH and triangle F prime G prime H prime. Let's use H. We're going to use H and H prime. So H was negative 3, 1. So remember that, negative 3, 1. So H prime is now negative 1, negative 3. I went from negative 3 to 1, and now 1 to negative 3. So that means my X and Y flipped spots. So I'm going to look up here and look at the ones that say, okay, I flipped spots. Well, it's either 1, 2, or 3. We just need to figure out what happened with those values. So if I had, in the beginning, negative 3, 1, and it is now negative 1, negative 3. My negative 3 stayed negative. So that X value stayed negative. The Y value is the one that became negative. So don't be fooled by these over here where it says that it's negative. That means that it's changed the sign. If they stayed negative, because it was negative in the beginning, it's going to remain the same, and that Y changed signs. So let's look at this one. So I have trapezoid PQRS and trapezoid P prime, Q prime, R prime, S prime. So what I'm going to do is I want to pick a point. I'm going to pick, let's go with R. Okay. R was 2, negative 4. Now if I look at R prime, it is negative 2, positive 4. So what happened with this one? Well, my X and Y stayed in the same position because I had 2, negative 4, and now I have negative 2, positive 4. All that happened is I changed signs for both of them because it's a 180-degree turn. So I'm going to have negative X, negative Y because they changed signs. Okay, last type of transformation we have is a dilation. Dilation is just like what we did with similar figures where I make things bigger and smaller. So if I have a scale factor of 2, that means every single point on my graph is going to be multiplied by 2. And that means all the side lengths are going to be doubled. Now, I can't say what this side length is because it's on a diagonal. So the only way I can dilate this figure is if I use my points and multiply. So if I start right here, this is 0.22. 2, 2, and I multiply by 2 will get me 4, 4. So I'm going to put a new point on 4, 4. If I look over here, this point is 3, 0. So I'm going to use 3, 0, multiply by 2. I'm going to get, well, 3 times 2 is 6. 0 times 2 is still 0. So 6, 0. So your new point's going to be right here. Over here, I have 1, 0. If I multiply everything here by 2, I'm going to get 2, 0. And your last point, 2, negative 2, multiplied by 2 is 4, negative 4. So I'm going to count over 4 and down 4, 1, 2, 3, 4. There we go. So I'm going to draw in our new shape. And there is our new diamond. And we have dilated it by a scale factor of 2. Okay, so just like we talked about with similar figures, when I have an enlargement, it is a number greater than 1 that I'm multiplying by. When I have a reduction, it is a number less than 1 that I'm multiplying by. So you'll see a fraction or a decimal. So this one's saying a dilation rule of 4x and 4y. Well, we just said that if it's bigger than 1, that means it's an enlargement. So I have 2 that say an enlargement. Well, and one of them says an enlargement of a factor of 3. Well, I have a 4 in the problem. So enlargement of a scale factor of 4 is the one that I'm looking for. This one has 1/3 x and 1/3 y. So is it a reduction or an enlargement? Well, it's a fraction, so I'm getting smaller. And the ones that I have for reduction, reduction of a scale factor of 1/4, reduction of a scale factor of 1/3. Well, I only have 1/3 in the problem, so it cannot be 1/4. So use process of elimination to figure out what the answer would be. In this case, it would be a reduction of a scale factor of 1/3. Okay, guys, so that is it for transformations. If you have any questions, please make sure you sign up for office hours, and I'm able to help you as much as I can. Bye-bye.